All right, so here I am in my attic getting ready to do exam 2 review. So here we go. All right, so for this review, I'm just going to go through the questions on the exam and sort of give you some hints. This is what I typically do in class. So we'll see how it goes. All right, so the first question, which of the following is not best practice as per your marketing research professor? So something ChatGPT might not necessarily know. And the key to you getting this answer right will be buying into my idea that we can work the whole marketing research project almost from start to finish before we collect any real data. So sometimes I say things like, go ahead and produce results and show them to people and say, hey, if I showed you this, would you know what to do? What decision to make? Or sometimes I say, hey, generate fake data. And people are like, fake data. But generate data the way you think people would answer and run your analyses and produce your slides and show your fake data slides to people. And if they say, if it works out like this, I know what to do. If it doesn't work out like this, I'll make different decisions. And you can do that before spending any money, really. The bulk of money spent on marketing research projects ends up being in the sample. So, especially when you're new, you can avoid making exceptionally costly mistakes by just going ahead and essentially conducting the whole study from start to finish with fake data and all the way through the PowerPoint presentation. Then, like, at some point, you can even set all your analyses up, and then at that point, once you've checked all the boxes and gotten approval for everybody, just a matter of collecting the data, pressing go on your analysis that you've already set up, and you're good to go. So anyway, all right. So that's question 1. Question 2. Professor Mike Giebelhausen has created a surefire process for developing high-quality reflective measures. What step in this process is conceptually similar to probing? So we talked about in class how qualitative research and probing in qualitative research is kind of similar to something we do when we're developing our own measures. So if you've been in class at all, you've probably heard me say that several times. All right, question 3. What Marvel Universe character is the most powerful? This debate is rooted in which marketing research topic? So you could think about what topics we've discussed this section of the course. You could think about maybe what the picture is on the Canvas card is what they call it. Canvas card for the course in Canvas. A hint there. Which of the following constructs would likely require a multi-dimensional scale? So a scale that has more than one dimension to it. So there's a lot of terminology we talked about in scales. We talked about scale points, so 5, 7, 9, 11 points. We talked about items, which are the individual rows. We talked about probably other things, but one of the things we did also talked about is a multi-dimensional scale. Which one of these concepts that are listed here would be most likely to require such a thing, i.e. the one that has more than one dimension to it. All right, data that has generated by a question that asks participants to rank something. So we talked briefly about nominal, ordinal, interval, and ratio data, which is a kind of different types of data. Nominal being just names, ordinal being some sort of inherent order to the whatever you're looking at. Interval being the things we look at most in this class, which are things like Likert scales and semantic differentials, where the points between the little dots that you're going to click are assumed to be the same distance. And then lastly, things like ratio level data, which are often open-ended. And the key to those is that there's some sort of zero that makes sense. So you could put in a zero. And usually where we find those is how many times a week do you eat pizza? And it could be 0, it could be 10, whatever. So that's where we usually find ratio level data. And as we go up the scale, we are able to do more things with the data. So, all right, and we all know I hate ranking data, so there's that too. And never do it. Never do it. All right. Psychometrically speaking, which would be the more sensitive scale? Ooh, sensitivity. So you may look at the debate between single item and multi-item measures for this one, because one of the characteristics for any scale really that we look at is how sensitive it is, and sensitivity means something particular in the context of psychometrics. Which of the following is not a valid statement about why it's almost always a bad idea to use a yes-no question? So I hate yes-no questions. Almost rarely are they useful. And so more often than not, you'll get yourself into trouble. If you find yourself using a yes-no question, the chances are you could have pulled that yes-no into probably not at all, very much, or never, frequently. Instead of something that's like this, we would have something that looks more like this, right? So that's what we ideally want. So my goal is to create a single item measure that will rate attitudes towards X. So attitudes towards X. Most people are enthusiastic fans of X, or some people are ambivalent about it. Rarely people feel negatively. How many scale points would I recommend? So a common mistake people make is having too few scale points. Again, something we've talked about in here is ultimately what we want to do. If we're going to be doing sort of correlation style research, which means we're going to be looking at movement in something we think might be causal and something we might be in effect, and we're going to be looking for those things to move together. Maybe this is a better graph like this. And if that's the idea, then we need things that have some kind of movement to them. If something like this, say I measured something that's a constant. Say, do you attend Clemson? And all my participants were Clemson students, and I had something moving over here, up and down, a dependent variable. I couldn't say whether being like something about studentness is correlated with that, because this is just a constant, so it has no movement, so it can't correlate with anything. In order for it to correlate with anything, positively or negatively, it has to have some movement of its own. So I think that's important to this question. Unstructured questions, I'm a big fan. So we know that as much. Many people aren't a big fan. They say they're too hard for people, or people will lie on them, or people will put in text, which are all weak arguments in my experience. People typically tell the truth and people typically, if you ask them to write in a number, they write in a number. And also on Qualtrics, you can click a little box that only lets them write in a number. Maybe they have a little data cleaning that comes along with them, but usually the data quality is much better. So anyway, big fan. Not everybody is out there in the world. All right. Oh, then there's the question you all knew was coming about my result is a sample of Clemson college students acceptable, given certain assumptions. All right. Which of the following statements is not true? Ooh, another tricky one. This is a lot of little factoids about sampling. So these are mostly in either the readings. Oh, so here's one. There's one of these is from the readings about MTurk data. Another one is how to estimate standard deviation for a population characteristic. So yeah, let's just talk about this briefly. So when we're estimating a sample size that we might need for any sort of study, there's lots of sample size calculators out there, and often they'll ask you to supply them for information. And one of the pieces of information they often ask you for is the standard deviation of whatever population parameter you're looking at. So remember, in thinking about p-values, we have multiple ingredients in getting to a p-value, right? We have the sample size. Bigger tends to help us get to small p-values. We have consistency of the effect and size of the effect. And so often these sample size calculators will ask you, how big of an effect do you want to be able to detect? And you can sort of tell them that, small, medium, large. And then we'll say, like, what's the consistency of the data? And so essentially, in those situations, when you're asked to estimate that, what you need to do is think about the range that 95% of the data will fall into. Like, let's just not worry about outliers too much at this point, but think of like the bulk of the data, 99% of the data, where that will fall into. And then what we want to do is we want to take that range and we want to divide it by 4. So let's say we're going to have a 7-point scale, and we're measuring something that everybody loves. And so we think that all of the responses are going to be either 6 or 7, which is problematic on its own because that's a ceiling effect. But let's just say that's what we're dealing with. And in that case, our standard deviation would be like the range, which is going to be 2 divided by 4. Because we would then get to 0.05. So some people say divide by 6. If you divide by 6, your standard deviation is going to be smaller. If you divide by 4, it's going to be a bigger, which will result in your sample size calculator giving you a larger sample size. Because if you say we have a lot more variation in the data, it will say, oh, well then to compensate for that variation, you need more sample size. So all things, in this space often boil down to these 3 characteristics, which are the size of the effect, the consistency of the effect, and the amount of data. So it's not a surprise that if you use a sample size calculator, it will be asking you for one of those things. And so one of the tricky things sometimes is to estimate how much variation there will be in the data. And one way to do that is this rule of thumb, where you take what you think the range of the data will be, and you divide it by something. Some people say 4, some people say 6. If you're on the, if you want to be conservative, you use 4 because that'll give you a bigger number of variation, which means more sample. If you're feeling bold, then you would divide by 6, which would result in a smaller sample size you would need for your study. So, all right, moving on. Oh, I like this one. Let's see. What sampling approach would you recommend if you don't have a lot of money? So when I talk about sampling, I've talked about a couple of things. We see typically companies make 2 mistakes, and they're sort of related but from the opposite direction. So one of those mistakes is that they will say, oh, we're going to assume that that demographics or whatever make a difference. Therefore, we're going to pay a lot of money and make sure we have representative samples on all these different demographics. And now, once we're going to throw them into a big pot and our job is done. And the problem with that approach is we're not actually checking to see if the demographics made a difference. Right? And so oftentimes we have situations where it turns out you didn't really need to do that at all. Right? So the hot cup example. Other times, we have these situations where companies either, underestimate the importance and sort of ignore demographics, or they pay a lot of money and end up but how they recognize the importance of these sort of smaller groups, but then they just throw them into a big pot and ignore them. So if you have a group that's only 10% of your population and it doesn't get its own analysis, whether that's its own bar chart or its own X variable in the regression analysis, then it just sort of blends in with everything else. It kind of gets drowned out by the bigger groups. So, what I sort of advocate is measure things that are important and include them in the analysis. And if for some reason you believe that those individual differences are not going to be present in the sample, then you may have to make sure they're there. But as a first step, just measure the things that are important and make sure you analyze them. So that's one way to do it. Okay. Directional hypotheses. So I would just say about this, the philosophical viewpoint on statistics is that they are there as a way of sort of self-policing ourselves. It's a way of restricting ourselves from saying something is true when it's not. So the type 1 error or false positive. So it's very easy to look at data and just like start making statements about it. And essentially what statistics is for is to say, are you allowed to make that statement? And we're allowed if the p-value tells us whatever you're looking at was unlikely to have just occurred by random chance. That's essentially what a p-value is doing. And so in that sort of paradigm where statistics and computing p-values is an act of sort of self-restraint or a mechanism for self-restraint, if we have another mechanism for self-restraint, which is specifying hypotheses before we do our test, then maybe we can get away with a little less self-restraint over on the p-value side. So if you have a directional hypothesis where you're like, I'm all in on a negative correlation or I'm all in on a positive correlation, then arguably you're not, if you're all in on a negative correlation, then even if you find a statistically significant positive one, it doesn't matter because, by accident, doesn't matter because you're not going to interpret it. So in that case, you can sort of take your chips and slide them over to the negative side. And in that case, you can use 0.10 as your cutoff. So when you're doing statistics, in all statistics, like the stats packages will assume the most conservative case. So they will assume you are looking for either a positive correlation or a negative correlation. You don't care. As long as you find something that's unlikely to have happened by chance, you're going to run with it. If that's so that when it's giving you those p-values, that's what it's assuming. So if that's not the case, if like only a negative correlation is going to work for you, positive correlation does you no good, then you can sort of again slide those chips over to that side and use that p and up, and it's still going to give you this more conservative p-value, but you can sort of just use the 0.10 benchmark instead of 0.05. All right, let's see. Where are we at? Reverse coded items. I think that's fairly self-explanatory. I personally just use them as, I personally sort of recommend against them. So people will put reverse coded means like it goes from like, oh, something was bad, something was good, something was negative, something was positive, something was favorable, something was unfavorable. On that last one, what I did is I switched the order so that the good thing was on the left and the bad thing was on the right. Now, the idea there is that there's a few ideas around there. One is that we can catch people, but the problem is we catch too many people not getting that right, and we end up throwing out tons of data. And then that's problematic because it's like, well, why did you have to throw out a third of your sample? That's a problem. So the other way to deal with it then is to reverse code it. So you take all the ones and turn them into sevens, take all the twos and turn them into sixes, the threes to fives, the fours get to stay the same, the fives go to threes, the sixes go to twos, and the sevens go to ones. Okay, so you do that process and then you combine them. The problem is, not everybody noticed. So you're reverse coding things that shouldn't be reverse coded. So you end up sort of polluting the data with mistakes that people made. So end up what you do really in practice is throw them out. So why would you put something in a survey, which we always try to keep short, that you're just going to throw out? The only reason I can think of is that if you are trying to slow people down, you throw it in there to kind of like, oh, wait, you throw a few in there just to let them know there's going to be some tricks, but you're not actually going to use that data. That's one use for them. Also, you could use them very systematically if you went like, if you had like say you had an 8-item measure where 4 of them were going left to right and the other 4 were going in the opposite direction, and in the stem of the question you put in big bold letters, note, 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 these items are reversed every other one. And maybe down in the items themselves you had a white row and then a gray row for the negative one and a white one for the positively associated, and then another gray row for everything you can do to make sure people don't, as they're speeding through, don't just read the first one and I'll go all the way down, because that does happen. So sadly, but so there's that. All right, what's up next? Some true false questions here about what about good practice in designing questions. I said questions. All right, so they're not questions, right? They are measures or scales of some certain number of points and some certain number of items. All right. So 8. So we know best practices. And 19. What are some things that suboptimal tendencies marketing research folks do? So I'm going to put the don't do this slides up in the slides after this. So look for those slides and read through them, and then you can answer this question. So into your GPT, load those slides as well. Then there'll be a picture of some regression output, which you'll have to interpret. So I think we've gone through interpreting regression output. Again, just a review. Maybe you look at the R squared to see how much variation in the Y you were able to explain with the X's. Then maybe you just glance briefly at the adjusted R square. Always it'll be lower than the R square, because surely there'll be something in your data, in your model, that doesn't do as good a job at predicting stuff. But not too much for concern. You'll skip over the ANOVA, because if you explained anything at all, then probably the ANOVA is going to be statistically significant at a very high level. And then you'll go down and you'll start working your way down the p-values. Anything that is less than 0.05, yay! Anything that's more than 0.10, oh. Anything that's in between 0.05 and 0.10, we can sort of think about, did we have an a priori, or did we have a specific coefficient correlation in mind? What did we expect would it make sense if we took the correlation coefficient and changed the sign? If it would potentially make sense, then we have to live with our 0.05 rule. If it's like, no, we weren't even thinking about that, we would, if it had been the other way, we wouldn't have interpreted it, i.e. we hypothesized it in advance, then we could use our 0.10 as our cutoff. And then we would interpret the coefficients. We might look at the coefficients to see which one was biggest, to see, that might provide us with some insight into what is important. However, we must always temper that evaluation with making sure that all of those measures were measured on the same scale. So a 7-point scale, for example. Because once they start, because remember what the interpretation is, it's a 1-unit change in whatever that X is, gets us how many units a change in Y. So if they're measured on drastically different scales, going from 0 to 1 in a yes-no scale, which would not be a good idea anyway, but if we did that, it would be a massive change. Going from I make $120,000 a year to I make $120,000 a year and $1 more is not a big change, right? So there you have that. So I think that gets us through the next big set of questions. Then there's a couple cute ones about thinking about internal reliability, and how when we're thinking about reflective scales, essentially, remember they should be the items themselves should sort of all tap into the same idea. The idea behind reflective scales is that they all reflect they're all a reflection in some sense of the construct. Maybe it's from slightly different angles, but essentially they all mean all the items are going to be tapping into the same idea. This is when we think about a reflective construct, this is what it's all about. Formative constructs are, we're sort of piling up evidence of that something exists, and they may not necessarily, sometimes we even do yes, no's. So we might have 30 different things, 30 different pieces of evidence, and we might ask for yes, no's on all those. Those are more psych scales, but at any rate, the more of those we see, or the more we say that this other sort of invisible thing is likely to be present. All right. There's probably a cool analogy from like science or carbon decay or something, but I don't know what it is. All right. When do we use different types of formative scales? So remember, if we have synonyms and antonyms, that's a semantic differential sort of situation. If we have lots of synonyms for something, but maybe not so many antonyms, that's what we call a hybrid. If it's a little more nuanced than that, and we can't really boil it down to one word, but we can come up with statements that people might agree or disagree with, then that is a Likert style. I have a scale design. Scale, some more and scale best practices have kind of come in at the end here. I guess, yeah. And that's it. So remember, so for those, again, when we are measuring things, what we're trying to do is generate sort of normally distributed data that is sensitive enough to capture variation that exists within the construct. So if we have data that looks like this, then that's probably that these are 2 bars, and now that's probably bad. If we have data that sort of looks like a lot of bars that kind of go like this in sort of a normal distribution, then that's probably good. So one of the assumptions of the general linear model. So all right, I think that's it. There's only really 3 slides plus the one extra that I'm going to post on things not to do in marketing research. And good luck with the exam. We'll see you soon. Bye.